Welcome to a new video which is about limit in logarithmic functions. In this video I will show you the property used to solve such questions and then solve instructive and challenging questions regarding the subject. If this is your first time here and if you want to support this channel, don't forget to subscribe. Click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. We have a remark guys here, and that remark is used to solve such questions. And it says, suppose that logarithm of limit when x goes to a of f of x is defined. Generally that function is defined and there is a domain and there is a range, but I didn't put it there. So in such definitions guys, we can just bring that limit inside of the logarithm, okay, as we see here. That limit right now brought inside of the logarithm, and we just basically make the calculations. And we have an example here, and it says what is the value of that limit when x goes to 2. Basically guys, we can solve this question into two ways. The first way is the regular way that we have here, and we're going to bring just this limit, okay, inside two functions. We have one function here and then we have another function here. So once we do it, we're going to have limit when x goes to 2 of 2x minus logarithm in base 5, and then I'm going to bring limit here, limit when x goes to 2, 3x minus 1 is equal to what? Well, this is just a polynomial, basic polynomial function. We're going to just put 2 instead of x. Basically, we're going to just evaluate the function. That's what we're going to do here. So 2 times 2 is going to be 4, guys. We're going to have 4 from here minus logarithm in base 5. Again, we will do the same thing. Just put 2 instead of x and just evaluate this function. So 3 times 2 is 6. 6 minus 1 is 5. So this part is going to be 5, guys. So we're going to have from here just 5. And when those numbers are same, 5 and 5, then this value is going to be 1, guys. So the result is going to be 4 minus 1, which is 3, guys. And let's take a look at our next question. And in this example, guys, again, we have a similar question. And question can be solved into two ways. The first way is this, by using this remark. And the second, and which is the easier way, I believe, is just put that 3, okay, instead of x, and that's all what we're going to do. So if you put 3 instead of x, then we're going to have logarithm in base 2, put 3, so we're going to have 5 times 3 squared is 9 plus 3 divided by 3, guys. So this is going to be equal to logarithm in base 2, 5 times 9 is 45, 45 plus 3 is 48, 48 divided by 3 is going to be 16. So the inside is 16, and 16 can be written as, okay, just let me write it here, 16 is 2 times 2 times 2 times 2. So this is equal to, guys, 2 to the power of 4. So I'm going to put here just 2 to the power of 4, and that 4 can come in front of the logarithm, which is going to make the whole result 4 times logarithm in base 2 of 2. So this is 1, guys. So the result is 4 times 1, which is 4, guys. And let's continue with the next example. Okay, guys, this question is a nice question because we need to bring the limit very inside. And once we do it, we're going to have a logarithm in base 2 of limit when x goes to positive infinity, 8x squared plus 4x minus 1 divided by 2x squared plus 4. So we need to evaluate this limit first in order to solve the question. And there is an easier and there is a longer way. And the easier way is just look at the highest powers, okay? Highest power is x squared in the numerator and the highest power is x squared in the denominator. Because they are equal to each other, we will just take the ratio of the coefficients. So the result is going to be just 8 divided by 2, guys. Then the longer way is just take the numerator in x squared parentheses, okay? So we're going to have 8 plus 4 divided by x minus 1 divided by x squared divided by, take the denominator in x squared parentheses again. So we're going to have from here 2 plus 4 divided by x squared. And then this is limit when x goes to infinity, guys. Those x squared values are gone. So when x goes to infinity, this is 0, this is 0, this is 0. The leftover is 8 and 2. So just divide those values, and we're going to have 4 from here. So this is the longer way, but in schools, this is the way that you're supposed to do it. But if you are taking a test, I recommend you to solve it in my way, which is the shorter way in this question. So just divide 8 by 2, then we're going to have 4, guys. So the question becomes logarithm in base 2, and we're going to have 4 here. So 4 is what? 2 square. So this expression becomes logarithm in base 2, 2 square. That 2 comes up front, so it's going to be 2 times logarithm in base 2 of 2. This is 1 already, so it's going to be 2 times 1, which is 2, guys. So the result of this question is 2. And let's take a look at our last question in this video. And this is our last question, guys, in this video. The question looks like a difficult question, but actually it's not. By using just one simple property of logarithms, we can easily solve the question, guys. So if you remember, there was a property like logarithm x of a, logarithm x of b is equal to, guys, because the bases are same, so we can just write the whole term as logarithm in base x a divided by b, guys. So this is what we're going to use in this question. Before taking the limit inside, I'll rewrite the very inside one more time, okay? So in the next step, we're going to have limit when x goes to positive infinity, guys. I'm going to have logarithm in base 2, and here we're going to have a fraction. The square root, we're going to have 8x squared plus x plus 1. In the denominator, we're going to have 2x squared minus 2 plus 4, guys. And because we are dividing a square root by another square root, and because the root degrees are same, so I can put them under one root, guys, like this. So I'm going to have 8x squared plus x plus 1 divided by 2x squared minus, this is going to be x, by the way, here, right? This is x minus x plus 4, guys. And now I can bring limit here, guys, okay? Limit when x goes to infinity. And now I'm going to apply the limit here. Think that this limit goes inside. Again, after this point, there is a shorter and there is a longer way. And the shorter way is, actually, I already showed you how to do the longer way. So I will just apply the shorter way here. So because the highest degree of the numerator is x squared, okay, and its coefficient is 8, I'm going to just look at 8. And the highest degree of the denominator is x squared, and its coefficient is 2. So I'm going to just take 2. Because there is x squared and there is x squared in both numerator and denominator, that is why I can take 8 and 2 and then just divide them. So I'm going to have logarithm in base 2 square root of 8 divided by 2, guys. So square root of 8 divided by 2 is square root of 4, and square root of 4 comes out as 2. So we're going to have logarithm in base 2 of 2, and that is 1, guys. And sometimes the questions may look like very difficult, but by just using one property, we can easily solve such questions, guys. And this question was our last question in this video. If you have any question, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.